Welcome, mathematicians, to another math video. Today's target is mean absolute deviation. And before we go on, I just want to let you know that it sounds a lot more complicated than it is. So let's get started. All right, so what is the mean absolute deviation? Well, it's the average distance. So there's mean, average distance between each data value and the mean. So we'll kind of go step by step through this. So here's the data. So 3, 5, 6, 7, 8, and 10. And again, I think it's a good habit to get into is ordering your data from least to greatest. It does help you see things when you do that. So when I look at the data, step 1, when you find mean absolute deviation, find the mean of the data. So I add them all up, and then I divide by 6 pieces of data. And my mean is 6 5/10. So that's step 1. So then I'm gonna create a number line here, and I'm gonna mark the mean. So 6.5. I marked it in blue, and then I'm gonna also kind of take note of my other pieces of data. So now, what you're finding is, as it states up here in the definition, the average distance between each data value and the mean. So we're going to look at each piece of data and how far away it is from the mean. And it's absolute, meaning that the positive or negative, like if we think of 0 and there's negative to the left and positive to the right, because it's absolute, in a sense the negative is going to go away, and we're dealing with distance, so it's just going to be a positive value. So let's look at 6 and 7. They're both in my data set. So how far away is 6 from 6.5? So I did a little line there, up and over. So if you look, the distance away from the mean is 0.5 or 5/10. So 6 is 5/10 away from 6.5. 7 also is 5/10 away from 6.5. So remember, we're looking just for the distance away from the mean for each piece of data. So I have 5/10, I have 5/10. Then when I look at, let's look at our 5 and then our 8. How far is 5 away from the mean? Here's my mean. Well, it's 1.5. It's 1.5 numbers away. 8 is also 1.5 away from the mean of 6.5. So let's look at 3, and then let's look at 10. Now, in my case, everything worked out perfectly where it is pretty symmetrical. It doesn't always have to be. So sometimes you're going to see a slight variation where on this side it may be this, on this side it may be 1, or slightly off. Just know it won't always be perfect. Now, let's look at 3. How far away is 3 from 6.5? Well, it's 3.5 away. The distance is 3.5 away from the mean. The same is for 10. So 6.5 to 10 has a distance of 3.5. So then what do we do with that? We have all these separate distances, which I marked in red. You can see all of those. What we do is we're going to add up the absolute distances, and those distances are to the mean, which was right here. And then we're going to divide by the number of distances. So how many are there? In a sense, how many pieces of data do we have? So I'm going to divide by 6. All right, so here we go. So I added all 6 of my absolute distances from the mean. So I have 5/10 plus 5/10 plus 1.5 plus 1.5 plus 3.5 plus 3.5. I divided by the number of pieces of data we had, so 6. So the average distance, each value is from the mean, is 1.83. So 1 in 83 hundredths. So what it's telling us is, in this case, the data is actually pretty close together from the mean, so it's not a very spread out data. So this is a great indicator of how spread out your data is, if you have a lot of extreme values or not so much. But this right here would be your final answer. 1 in 83 hundredths would be the mean absolute deviation for that data that I showed you before. All right, so we'll make sure we do lots of practice. And again, if we just follow those steps, so you find the mean first, then you calculate each distance, absolute distance, of each data set to the mean, then you add them up, divide by the number of pieces of data, and then you have your mean absolute deviation. All right? Go ahead and bring your notes to class. They'll be a great resource for you during our practice time. And thanks for watching.